Today's topic is projectile motion. When a particle is projected at an angle with horizontal, then this object is called projectile. Now when it is thrown at an angle which is less than 90 degree, then it covers a path like this. Now at the point of launching this U, if the angle of projection is theta, then this U can be resolved into two components. One is vertical, that is U sin theta, and the horizontal component U cos theta. Now gravity acts perpendicular to this component, this U cos theta, and this is weight of the body. This gravity acts at an angle 90 degree with this horizontal component. That means this gravity has no component along this U cos theta, either this way or that way. mg has no component along U cos theta or against U cos theta. That means mg has no effect on U cos theta. It neither increases U cos theta nor reduces U cos theta. So it has no effect on this. So U cos theta is uniform component because mg has no component along this or along this direction. So U cos theta's value remains always constant, but U sin theta is such a component up to this point, up to the topmost point, gravity acts against U sin theta. That means gravity tries to reduce the effect of U sin theta up to this point. After that, the directions of gravity and U sin theta are same. So gravity favors U sin theta. That means U sin theta increases in the next half of journey and reduces in the previous part of journey. If we draw the components at various points of the trajectory, then clearly it is seen that this angle theta gradually decreases and ultimately it becomes 0 here. It becomes 0. If this angle is decreasing, that means U sin theta decreasing, U cos theta remains same. U cos theta gradually increases. U cos theta gradually increases. When here theta is equal to 0 degree, then U sin theta completely becomes 0 and U cos theta becomes U. That means at the topmost point of the projectile only U remains, and that is horizontal, but there is no vertical part of the speech, that is U sin theta is absent here. Only at this top point the projectile has horizontal motion, no vertical movement further. After that, this angle from 0 gradually increases. Gradually increases, that means u cos theta decreases, u sin theta increases, and as a result it will increase vertically. At this point there is only the vertical component, no horizontal component, and it drops, it touches the ground at this point. That means it is a uniform component, it is an uniform component, and this is varying component. Varying component. This decreases up to the top, and next part it increases. So it is varying component, and it is uniform component or constant component. Now if we consider the two components separately, then what happens? If we consider the horizontal motion or horizontal component, if we consider horizontal component, then we know that in case of uniform velocity, the relation is S is equal to Vt. Now the horizontal maximum distance covered by the projectile is called its range. This range can be now put here. R is equal to, this V is the horizontal component of u, that means u cos theta into t. T, what is t? Now R is the range of projectile, T is total time of journey, H is the maximum height it can reach, maximum height reaches, and T prime, suppose time to reach the top. Let's consider these four terms R, T, H, T prime. If we consider the vertical component, then what happens? It is varying component, and up to the top the maximum height or vertical displacement is h, and at the top if we consider u sin theta, that means the vertical component, at the top it becomes 0. U sin theta, theta is 0 here, so u sin theta becomes 0. So if we use the relation V is equal to u plus at, then it will be replaced by 0. It will be replaced by u sin theta. The sign would be negative, since against gravity the journey is. A is g, and t is the time to reach the top, that is t prime. So from here we get t prime is equal to u sin theta by g. This is the time to reach the top. Now if we consider, let's write here, S is equal to Vt, so R is equal to u cos theta into t. Now if we consider the total journey, if we consider the vertical component, that means it starts from which level ultimately after the journey ends, it reaches the same level. From which level it starts to the same level it reaches. That means net vertical displacement. Suppose it starts from here and reaches here. That means there is a net vertical displacement, this part. This part is the net vertical displacement. But if it reaches here, then net vertical displacement is this. But if it reaches here, then there is no difference in levels between two. So there is no vertical displacement at all. So net vertical displacement is equal to 0. So if we use S is equal to ut plus half at squared, then net vertical displacement H is equal to H is equal to 0. This is H is equal to 0. So 0 is equal to, we have to take the vertical component u sine theta into total time of journey is considered as t, and it will be negative, and then half, this will be g, and this will be t squared. Solving this, we can get t is equal to 2u sine theta by g. You must remember, in the previous case we have found that the time to reach the top is equal to u sine theta by g. So this is the time to reach the top, and this is the time to complete the total journey. This is the time to reach here, and this is the time to complete the journey. That means the time to reach the top is half the time of total journey. So we can write t prime is equal to t by 2. Okay. Next, if we take the top position again, if we consider the top position again, the total, starting from here, the total vertical displacement from this level to that level is h. So if we use v square is equal to u square plus twice as, at the top the vertical component becomes 0, that means v0, and for u it will be u sine theta, that means u squared sine squared theta, it will be negative 2g h. From here h is equal to u squared sine squared theta by 2g. This is the expression of the topmost, it is the expression of the height it can reach, the projectile can reach. Now, previously we have seen that the total time of journey is t is equal to 2u sine theta by g. If we put this expression here, because when the projectile starts this way, that means it simultaneously starts moving upwards and forward, this way, this way, this way. That means it simultaneously moves like this and also like this, here and here, here and here, here and here. Simultaneously the two actions take place. That means in time t, it completes the total journey. That means it completes the vertical motion up to half, downwards motion up to next half, and the total horizontal distance means range. In time t, it covers the horizontal range r, the first half part towards up, next half part towards down. That means these two actions are taken place simultaneously. So considering the vertical motion, this t, and considering the horizontal motion, this t, these two t are same. So you can put this expression here. That means r is equal to u cos theta into 2u sin theta by g. That means, now if you u square and 2 cos theta sin theta together form sin 2 theta by g. That means when this range will be maximum, r will be maximum. In this expression, u is constant, because when the projectile is once projected, it cannot be taken back to this point with a new speed. So when it is already projected, that means u is fixed. So it is constant. It is already a constant for a certain place. So it completely depends on this angle on this trigonometrical ratio sin 2 theta. So r will be maximum when sin 2 theta will be maximum, and the maximum value of this is 1. It implies that 2 theta is equal to 90 degree and theta is equal to 45 degree. That means, suppose in Olympic, in any kind of international games, one event comes called javelin throw. So it is a kind of spear, pointed rod, long pointed steel rod, and it is thrown by the competitor and it reaches a certain distance. So the coach actually advises or trains the competitor months after months the action of his or her front arm, back arm, the angle of projection, that is 45 degree. If he or she can maintain that angle, if he throws the javelin like this, if he or she throws the javelin like this, this is the final range. This is the final range R, and this will be maximum when at the moment of throwing and all the time during his or her running before taking launching before the final launch. The angle of projection, if he or she maintains 45 degree, then it will reach the maximum range, maximum horizontal distance, and that is the most important part of training applied by the coach. Similarly, for a missile, the horizontal range from here, if it is launched, then to what extent it can reach, to which country it will cover. That means all the functions are to be executed properly, exactly, if the missile during its launch can maintain this angle. So this is the maximum, this is the angle for maximum range. And what will be the maximum range? The maximum range, you know, are is equal to u square sine 2 theta by g. So if this is 1, then R max will be u square by g. Then if you maintain 45 degree, this angle 45 degree, then you can increase your range by increasing your throwing speed. So suppose this is the projectile, this is y-axis, this is x-axis. So u cos theta acts along x-axis, u sin theta acts along y-axis. So if you, this is uniform component of its throwing speed. So you can use the formula of uniform motion, that is S is equal to Vt, and S here is the horizontal range. So S is equal to Vt. So from here T is equal to R by u cos theta. Now if you replace this R with X, since we now place the whole system in the Cartesian coordinate, so R is represented here by X, so it will be X. And if we consider the vertical component, then we can write S means the journey towards y-axis, that means y is equal to u sin theta, which is u t minus half gt square. T is the total time of journey. Now if you replace this t there, it will become u sin theta into x by u cos theta minus half into x square by u square cos square theta. So finally it comes tan theta into x plus minus g by u square cos